Welcome. Today we discuss a very important chapter, inverse circular function. And today we take its part 1, first part of that chapter. What is inverse circular function? I think you know. Suppose theta is equal to sine inverse x. It is an inverse circular function. Theta has two values. One is normally called principal value and other one is general value. From principal value, general value can be obtained using equation of trigonometric functions. General solution of trigonometric function. From there we can get that. Today's important thing is that what are principal value. For theta is equal to sine inverse x, a principal value is between minus pi by 2 less than or equal to theta less than or equal to pi by 2. That is, it is in between fourth quadrant to first quadrant. Minus pi by 2 is here, 2 pi by 2. And x, domain of x is minus 1 less than or equal to x less than or equal to 1. Similarly, for theta is equal to cos inverse x, its principal value lies between pi, that is, which is in from 0 to pi, that is first quadrant to second quadrant. This is that. And xm, domain of x minus 1 to plus 1. Theta is equal to tan inverse x. It is minus pi by 2 less than theta not equal to less than pi by 2. That is, it is again fourth quadrant and between fourth quadrant to first quadrant excepting the endpoints. So it is actually from this to that. It cannot touch this. And domain of x is minus infinity less than x less than infinity. Whenever we are asked to find the value of that, we must give the principal value. Now we discuss few properties. Number 1, sine inverse x it is, and because it is defined, so x must be within that domain minus 1 to plus 1. If it is there, then simply this is equal to x. And cos of cos inverse x, same x. Tan of tan inverse x, again x. Moreover, sine inverse sine theta, it is theta provided theta lies within that range, principal value. Similarly, cos inverse cos theta is equal to theta, tan inverse tan theta is equal to theta, if that theta lies within their principal values. Next one, another important property, very important, it will be used frequently. sum of sine inverse x plus cos inverse x. It is equal to pi by 2. Sine inverse x plus cos inverse x. Once again I am repeating, x must lie within their defined domain, that is -1 to +1. Similarly, tan inverse x plus cot inverse x is equal to pi by 2 if x is defined within that domain, that is it is -infinity to +infinity, and sec inverse x plus cosec inverse x, it is equal to pi by 2, and x must lie, x must be such that mod x is greater than 1. The next one is conversion. What is that? Just 1 minute. Conversion means from one inverse circular function to another inverse circular function. For example, it is sine inverse of x is equal to cos inverse of root over 1 minus x square. X must lie within their domain. Similarly, sine inverse x, cos inverse that, it is equal to tan inverse of x by root over 1 minus x square. This addition formula, sine inverse x plus sine inverse y, it is equal to sine inverse of x into root over 1 minus y square plus y into root over 1 minus x square. If it is negative, sine inverse x minus sine inverse y, then the formula is sine inverse x into this minus y into root over of 1 minus x square. And cos inverse x plus cos inverse y, it is simply cos inverse of xy minus root over of 1 minus x square into root over of 1 minus y square. Cos inverse x minus cos inverse y, it will be, this sign will be positive. I am not lengthening, just you remember, if it is negative, then that is positive. And finally, tan inverse x, it is very important. Tan inverse x plus tan inverse y, it is equal to tan inverse x plus y by 1 minus xy, provided if xy is less than 1. But if xy is greater than 1, in that case it is pi minus tan inverse x plus y by xy minus 1. Actually, we have to make it positive. So this is valid for when xy is greater than 1. And finally, tan inverse x minus tan inverse y, it is equal to tan inverse x minus y by 1 plus xy. Cot inverse x plus cot inverse y, this is equal to cot inverse xy minus 1 by y plus x, and cot inverse x minus cot inverse y is equal to xy plus 1 divided by y minus x. And just one more formula, tan inverse of three tan inverse functions, which is simply tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse x plus y plus z minus xyz by 1 minus xy minus yz minus zx. Now, with this formula and concept, let us now solve few problems. So our first problem is find the principal value of sine inverse tan minus 5 pi by 4 is there are options: pi by 4, pi by 2, minus pi by 4, and minus pi by 2. Actually, first simplify it. It is sine inverse tan of minus theta. So actually it is minus tan theta. Tan of minus theta is minus tan 5 pi by 4 is equal to sine inverse. It is minus tan of 5 pi by 4 can be written as pi plus pi by 4. And because multiplier of pi is 1, I mean pi by 2 is 2, so tan will be retained. And it lies in third quadrant. So it is sine inverse minus, this will be tan of pi by 4 is equal to sine inverse minus 1. Now, principal value of sine inverse minus 1. Sine inverse 1 is pi by 2. Sine inverse minus 1 is minus pi by 2. So it is minus pi by 2. So that option is correct. Next. The value of sine cos inverse tan sec inverse x, the value of that options root over of x square minus 2, root over of 2 minus x square, 1 by root over of x square plus 2, and finally minus 1 by root over of 2 plus x square. These are the options. So actually there are two inverse circular functions and two trigonometric functions. The way is we have to simplify from the end. Suppose sec inverse x is equal to a. So actually it is sec a is equal to a. Sec a is equal to x. Actually, and here you see sine cos inverse tan a. So we have to now find the value of tan a. We can do in different ways. Sec a is known, so tan a can be obtained. But, or from this considering one right angle triangle, it is by less time we can do that. Sec a, I mean cos a is equal to 1 by x cos a, so it is 1, it is x. Cos a is equal to 1 by x. So by Pythagoras theorem, this is root over of x square minus 1. We want tan a. Tan a is, so it is equal to sine cos inverse tan a. Tan a. Tan a is equal to this by that, root over of x square minus 1 by 1. Once again, we get another inverse function. Let it be b. So cos inverse root over of x square minus 1 is equal to b. So it is actually equal to, if this angle is b, cos b is equal to root over of x square minus 1. Cos b. Cos b, x, this by that, it is actually base divided by hypotenuse. So this is equal to x square minus 1. It is 1. So this one is 1 minus this square is this square minus that square. 1 minus x square minus 1. So that 2 minus x square, they are root. So that cos b is equal to that. We want sine, this is b. Sine b. Sine b is equal to this divided by 1. So root over of 2 minus x square by 1. So sine b, that is sine of this whole thing, it is b. So this is equal to root over of 2 minus x square. So this is our correct answer. Now, our next problem. Sine of sine inverse 1 by 3 plus sec inverse 3 plus cos of tan inverse half plus tan 2. Obviously, these 3, that 2, they are in terms of radians. Now it is equal to sine of sine inverse 1 by 3 plus cos of sec inverse x is cos inverse 1 by x. So it is 1 by 3 plus cos of tan inverse half plus cot inverse half. Now both are of the type sine inverse x plus cos inverse x, same, and that x lies within their domain. So it is pi by 2. Same case, this is pi by 2. So sine of pi by 2 plus cos of pi by 2. This is 1, this is 0. So answer is 1. Oh, option are not given. So actually there is one option. Options were 4, 3, 2, 1. So this option is correct. Next. The value of sine inverse sine 2 pi by 3 minus sine inverse sine 12 pi by 3 plus half cos inverse cos 5 pi by 3 minus cos inverse sine pi by 13. I think 12 pi by 13. This is 3, okay. This is 13. This is 3, okay. This is 13. Third bracket close. It is sine inverse sine something, but that one is not within principal value. So this cannot be equal to 2 pi by 3. It is sine inverse sine of pi minus pi by 3 minus sine inverse sine pi. It is minus pi by 3, 13. Plus half cos inverse cos of it is pi minus 2 pi by 3, or rather 2 pi minus pi by 3, 6 minus 1, 5 pi by 3, minus cos inverse sine pi by 13. Just 1 minute. It is equal to sine inverse sine pi minus pi by 3 is sine pi by 3 minus sine inverse. This is once again pi minus sine of pi minus 13. Then this one plus half cos inverse. This is in fourth quadrant, positive, and 2 pi. So cos inverse cos of pi by 3 minus cos inverse sine of pi by 13. Now consider this. It become now pi by 3. This become pi by 3 multiplied by half plus pi by 2 into 3. 2 is this 2. After that, this one and that one, it is taking minus common. It is sine inverse sine pi by 13 plus cos inverse sine pi by 13. That is, one is sine inverse sine pi by 13 plus cos inverse sine pi by 13, and before this and that both are negative, so minus of that. It is of the type sine inverse theta plus cos inverse sine inverse x plus cos inverse x. Both are within their range, so it is equal to pi by 2. So minus with this and that, it is pi by 2. So it is equal to pi by 3 plus pi by 6, that is pi by 2 minus pi by 2, so it is 0. Oh, options. Here also I forgot to give your options. So 0 is the option there. So answer is 0. Next. The value of cot inverse 9 plus cosec inverse root over 41 by 4. We have to add them. One is cot inverse, other is cosec inverse. But we have only formula sine inverse x plus sine inverse y, cos inverse x plus cos inverse y, tan inverse x plus tan inverse y, but not cot inverse plus cosec inverse, no formula is there. So we have to convert this and that both to tan inverse something. First one is very simple. It is tan inverse of 1 by 9. And this one, suppose cosec inverse root over 41 by 4 is equal to A. So cosec A is equal to root 41 by 4. Now construct a triangle, right angle triangle. This is A. Cosec A is this by that. So sine A is equal to 4 by, so it is 4. This is root over 41. So this must be equal to, by Pythagoras theorem, this square means root over of 41 minus 16. So it is 5. So tan, it is equal to, from there, tan A is equal to 4 by 5. So A is equal to tan inverse 4 by 5. A is equal to tan inverse 4 by 5. Actually, we have taken this as A. It is tan inverse 4 by 5. Now we can add. It is equal to tan inverse. This is x, this is y. X into y, it is less than 1. So ordinary formula, 1 by 9 plus 4 by 5 by 1 minus 1 by 9 into 4 by 5 is equal to tan inverse. LCM is 45. This is also 45. So 5 plus 36, it is root over of 41 by, it is 45 minus 4. Oh, not root over, sorry. So it is equal to tan inverse 41 by 41 is equal to tan inverse 1. So answer is tan inverse 1 is pi by 4. Oh, here also options are not given. Let us see. One option is, first option is pi by 4, then pi by 2, pi by 3 and pi by 6. So pi by 4 is correct answer. Next. Next problem. The value of cos inverse root over of 1 plus root over of 1 plus x square divided by 2 into root over 1 plus x square is equal to first option tan inverse x, second option half tan inverse x, third option is half cot inverse x, and fourth option is cot inverse x. To simplify it, let us take x is equal to tan theta, tan A say. So this is 1 plus tan square A, sec square A, considering root over, it is sec A. So it is equal to cos inverse root over of 1 plus, it is 1 plus tan square, sec square, so sec A. This is also sec A by 2 sec A. Now multiply numerator and denominator of that by cos A root over of, this is 1 and this is cos A, and here also only 2. So it is equal to cos inverse root over of 2 cos square A by 2 by 2. So 2 cancels, cos inverse root over cos square A by 2, so cos A by 2. So cos inverse cos is A by 2 is equal to half of A. A means I have taken A is equal to tan inverse x. So this option is correct. Next. If tan inverse root over of x into x plus 1 plus sine inverse root over of x square plus x plus 1 is pi by 2. Then value of x is value of x is oblique r. More than one answer may be correct. 0. Next one is 0, comma minus 1. Next option is 0, comma 1. Next option is 1 minus 1. So now here you see this one equation is given. So this is, and because it is given equation, we can say that this is defined, not undefined. In that case, x into this one, x into x plus 1, it is within root there. So it must be greater than or equal to 0. Here also, you see, this is actually equal to x into x plus 1 plus 1. So its value is greater than or equal to 1. This is greater than or equal to 0. This is 1. So greater than or equal to 1. But sine inverse that it is, that is the domain of that, if it is actually within minus 1 to plus 1. So it must be, as because it is valid So this must be 1. This one must be 1. And so this must be 0. So we get, and sine inverse 1 you see pi by 2, satisfying. So we must get x into x plus 1 is equal to 0, and this is x square plus x plus 1 is equal to 1. So because if it is, otherwise it is not possible to, for definition it is not possible. So actually we get this and that. Solving this we get x is equal to 0 and minus 1. Here also same thing, x is 1 cancels, x is equal to 0 and minus 1. So this option is correct. Okay, today is up to this. If you feel that it is helpful for you, please share it, like it, and subscribe it if not yet subscribed. Thank you.